Hello everyone. Am I audible and is the screen visible?
Yes, ma'am. Good afternoon, ma'am.
Good afternoon. Thank you for your response.
Yes,
Let's
ma'am.
wait.
You're audible.
Okay, thank you. So, to time we have started already recording. So let's just wait for 1 more minute and then we will start today's session. Let's begin with today's session. So, welcome everyone to the NPTEL course on novel technologies for food processing and shelf life extension. Professor H.N. Mishra is the instructor of this course of the Department of Agriculture and Food Engineering, IIT Kharagpur. I am Shikha Sharma. I am a research scholar in the Department of Chemical Engineering, IIT Guwahati, and I am the teaching assistant for this course for January 2025 semester. And I will be and today we will be discussing on the topic of week 7, which includes mainly the extraction and the processing of the oil, mechanical expellers, and then solvent extractions, different extractors, and then refining of the about refining and different processes like includes degumming and etc. And then hydrogenation, and then winterization. So, uh, if I hope you have already gone through the 5 lecture videos, which includes or which is covering all these topics. And in this live session, we will be practicing some of the numerical problems related to these topics, and we will be discussing some of the concepts which are applying. And if you have any doubt, please feel free to ask. Um, so let's begin with today's session. So today's topic will be extraction of the oil, refining of the oil, and modified fats. So this is the today's first question, which is asking about which of the following statements is not correct with respect to solvent extraction of oil. So option A says reducing oil viscosity promotes oil collection. Option B says temperature is increased to inactivate the enzymes. Option C says very high pressure temperature favors high oil yield. So as we know that oil extraction process, it includes two types of the uh, extraction processes. Like one is the mechanical extraction process and another is the solvent extraction process. So in mechanical extraction process, we use mainly we force and we press the oil cake oil seeds, mainly the oil seeds, they are crushed and they will be converted into fine powders, not very fine, but kind of like coarse powders. And then we apply the pressure on the coarse oil particles, and then oil will be released because of the pressure. In the solvent extraction process, the coarse particles of the oil seeds, they will be in contact with some of the solvent which uh, in which oil can be easily like dissolvable. So oil will dissolve in the solvent, and then further the solvent in the from the oil solvent mixture, the solvent will be evaporated and we will get oil as our product. So this is mainly happens in the oil extraction process. So as per the question, it is asking about the statements which is not correct with respect to the solvent extraction method of the oil. So about this method we are talking about. So option A is saying about if we reduce the viscosity of the oil, then it promotes the oil collection, means the yield increase. Second option is saying if we increase the temperature, then it deactivates or inactivates the enzyme. And third is saying that if we increase the temperature to a very high extent, then also there is a high oil yield. So anyone please?
B.
Option
B.
B.
B. B.
So we have attendance today around 17 people. So I'll be taking attendance in between any time. Because I'm observing that people are joining and then leaving in between. So I can take any time, either initially, in between, or at the end of the session. Okay, so most of us are saying B option. But answer is C. C is incorrect. A and B option, these statements are correct. So what happens when we thermally treat uh, uh, the oil seed? Oil seed is nothing but basically a plant cell. So when we thermally treat the plant cell, it ruptures its cell wall. The cell wall gets ruptured. So because the cell wall gets ruptured and there is a breakage of the covalent bonds between the lipids and the cellular matrix because of the heat treatment. So when we increase the temperature, there is a coagulation of the or denaturation of the protein also occurs, so which alters the lipoprotein membrane and reduces the viscosity of the oil, also increases the yield or the oil extractability. So what is happening when we are increasing the temperature, the plant cell wall they gets ruptured and the lipid which is bounded with the cellular wall or cellular matrix or the plant matrix, the covalent bond because of the high temperature it breaks and the lipid which is our oil, it gets easily extracted out. So also there are the proteins or different enzymes, they get breakdown, and as we discussed that the cell wall it breaks, it ruptures. So like lipoprotein membranes or the cell walls they breaks down, and due to high temperature, obviously if we increase the temperature the viscosity will going to be low. So if the viscosity will be low, so flowability of oil will increase and we get oil easily extracted out. So the statement B, which is temperature is increased, so option A, which is reducing oil viscosity promotes oil collection. So when we reduce the oil viscosity, it easily flows and our oil yield will increase. So option A is correct. And if we talk about B, it is saying that temperature is increased to inactivate the enzymes. So when temperature increase, enzymes they deactivate. The enzymes are nothing but they are proteins, right? So at high temperature, the proteins or the enzymes, they inactivates. So this statement is also correct. But statement 3, that if we increase the temperature very high, like however heating at very high temperature, it causes hardening of the material that reduces the oil yield. So because of the very increasing of very high temperature, so what happens, there are two reactions happen, like oxidative degradation of oil molecules happens, which leads to the formation of the peroxides or the other oxidative products. And also there is the, because at the high temperature there is a formation of the high molecular weight compounds. So what happens, because of the high temperature there is a possibility of thermal polymerization reaction, like because of the temperature polymerization reaction may happen, and there is a formation of high molecular weight compounds which can uh, block the oil passage, or uh, second is the oxidative degradation of oil molecules may also happen. So because of that extraction process becomes difficult. So at very high temperature yield decreases. Or additionally, the waxes and the gums, they also get solidify at the high temperature. So if they solidify, they will going to block the passage of the oil. So the yield will go down. So statement 3 is incorrect. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes.
ma'am.
So, so B is not correct. In this, B is a correct statement. C is not a correct statement. So please keep in mind when you are attempting this question. So we are moving to the second question of today's session, which is about which among the below given oil seeds does not require an additional pre-processing step before solvent extraction. So what happens? Sometimes we use multiple extraction steps, like in first slide we discussed about there are two extractions, like mechanical extraction, solvent extraction. So sometimes what we do is we use first mechanical extraction and then the solvent extraction, uh, so we can get more like more oil yield. So so in these oil seeds, like sometimes we use pre-processing step. Pre-pressing step means we are using first mechanical pressing and then we are using the solvent extraction. So sometimes we use and sometimes we do not use for some kinds of oil seeds. So we have four oil seeds here: sunflower, safflower, rapeseed, and soybean. So out of these, we need to identify in which we do not require an extra pre-pressing step uh, before the solvent extraction.
Soybean, ma'am.
A.
So, soybean and sunflower,
Soybean.
we got A and D.
Safflower.
Soybean.
Yes. Safflower. B.
I'm sorry.
B, ma'am.
B, safflower.
B. B.
So answer is D, soybean, because what happens, pre-pressing when we do is it refers to the initial mechanical pressing of oil seeds before we go for the solvent extraction stage. Because here what happens, some portion of the oil is physically squeezed out using a press, leaving a cake. Then that cake is further uh, processed with a solvent to extract the remaining oil. This is the pre-pressing. So in this process, only usually high oil content seeds we do pre-pressing and then solvent extraction, because it helps to reduce the solvent usage and overall improve the extraction efficiency. So the oil seeds which are given here, so soya bean, it is having around 20% by weight oil. Rapeseed is having 40% oil. Safflower is having 38% oil, and sunflower is having 42% oil. So all these three, A, B, and C, they are having high oil content. So if we use solvent extraction directly, so what will going to happen? We eventually require more solvent to uh, increase to take out more oil. So for these three seeds, what we do is we first do pre-pressing and then we will going to do the solvent extraction. Whereas in soya bean, pre-pressing step we do not generally go for, because it is having 20% of the oil, which is not very high. So we directly can go for solvent extraction. So in this soya bean, we do not need an extra pre-pressing step. So answer D is correct here. Is it clear to everyone who were like telling about A and B option?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So shall we
Yes,
move to
ma'am.
next question?
Yes, ma'am.
Yes, ma'am.
Okay. So next question is about matching the statements which are in column 1. The statements are like advantages as the hull reduce the total oil yield. Facilitate Second statement is facilitates oil extraction by disruptive effect of rolling and reducing distance. Statement 3 is reduction of the seeds in small particles by grinding. And column second is about the processes, respective processes like size reduction, flaking, and dehulling. So we need to match for the statements with their respective processes.
Ma'am, D.
So we get option D.
Yes, ma'am. D.
Ma'am,
D.
option D.
B.
So yes, you people are correct. D is the correct answer. So what happens in the pre-treatment of the raw oil seeds? So we do generally the pre-treatments in the oil seeds, because we need to get the high recovery of the oils. So about the dehulling, the hulls of the oil seed, they are having more of the fiber and low of oil content. So we do dehulling, means we remove the hull before the extraction process. So we can get, because hull will going to reduce the total oil yield and the capacity of the extraction equipment. So the if we do not remove hull, we will have more fiber and less of the oil. Also, this fiber can going to interact or can hamper the oil extraction yield. So dehulling is done. So dehulling, this is related to first, which is advantages as the hull reduces the total oil yield. Second is about the grinding, which is the small conversion in the small particle size. So the extraction of the oils from the oil seed, either by the mechanical extraction or by means of the solvents extraction. So it is more easily done if there is a size reduction of the seeds by the grinding process. So the size reduction is related to reduction of the seed in the small particles by grinding. Third is the flaking. Flaking means grain kernels are compressed between two counter rotating rolls. So grain will be there between two counter rotating rolls. It will be like, then because of that it will be like a flake when it passed through that. So it is essential because when we are uh, preparing the seeds for making the, like, for extracting the oil from the oil seeds, so then it facilitates oil extraction by disruptive effect of rolling as well. So when we do the flaking, there is a disruption in the oil seed, so it increases the oil extraction yield. Second is, if there is a less distance, it is like a flake, so there is a less distance, so oil can easily diffuse. So diffusion of the oil and the solvent by reducing the distance also helps in the oil extraction. So facilitate oil extraction by disruptive effect of the rolling and reducing distance is a flaking. So it's clear to everyone. We are moving to next question. This is about the
Yes, ma'am.
numerical.
Yes, ma'am.
Yes, so please uh, sit with your one paper and one pen so that we can solve this question together. So calculate the effectiveness in percentage of an oil expeller where yield is 37 kg oil containing 5% solid impurities from 100 kg mustard seeds having an oil content of 40%. So please, effectiveness we need to calculate of an expeller where yield is given as 37 kg of oil and 5% impurities it is having. This 37 kg oil, it is having 5% impurity, and this 37 kg is coming from 100 kg of mustard seed. So our feed of mustard seed is 100 kg, which has 40% of oil. So let's discuss the solution part. Amount of the mustard seed we are having 100 kg. On in this 40% is oil content. So the oil content in the mustard seed will be 100 into 40% of 100, which is 40 kg. So 40% means 40 divided by 100. So it is 0.4. So 0.4 of 100 kg of mustard seed, which is 40 kg oil, and 60 is not oil, non-oil part. Then, as per the question, oil expeller yields 37 kg of oil and has 5% of impurity. So we have input which is 40 kg oil, and then output is given that we are able to extract 37 kg oil which has 5% impurity. So effectiveness will be output divided by input mostly. So output is 37 kg of oil, but it has 95%. It has 95% purity but 5% impurity. So 100 minus 0.05, because 5% means 5 by 100. So 5 by 100 equals to 0.05. So 100 minus 0.05 is the pure amount, which is 0.95. So into 0.95 divide by output, which is 40, and since we need to calculate the percentage, if 40 into 0.95 into 100, so it is going to give 87.88% of the effectiveness of the oil expeller. Is it clear, this question?
Okay, ma'am.
Yes,
Okay.
ma'am.
Okay.
Yes, ma'am.
Okay. So option. Now let's move to the next question. For that, I check how many have joined. Okay. Okay. So identify the oil extractor type given in the figure.
A.
Given in the figure. So this is the extractor. These are the different extractors like basket extractor, Ballman extractor, rotocell extractor, or Hildebrand extractor. So which is the
Option A,
correct
ma'am.
option?
Option A.
So
Option A,
we
ma'am.
get
Option A,
option
madam.
A. Everyone is on option A.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
A is correct answer. So this is Hildebrand extractor, which is also known as, which is a immersion type extractor, a continuous immersion type extractor, where it is a vertical kind of extractor. There is a U shape where feed is coming from here, solvent is coming from here, and extracted the oil and the solvent is going here, and extracted meal will go out from here. So it is a vertical extractor which is U shaped, and the total immersion extractor, it consists of the 3 screws basically. So one each in vertical legs, and one is the horizontal section of the barrel. So there are 3 screws, one in horizontal and 2 are in vertical. The helical profile of the screw is perforated to allow flow of the oil. So it is perforated because we need to flow the oil. The solid is fed at the top of the one leg. So here we are feeding the feed, and solvent is fed from the another leg, the top of the another leg, and then it will flow counter current to solids through the perforation. So it will going to flow in the opposite direction. If the feed is flowing like this, oil will going to flow like this. Oh, sorry, solvent is going to flow like this, and the diffusion of oil happens. The rich micella is withdrawn through a strainer for further treatment, and solvent is going to separate. And another, if extractors, if we talk about, the Ballman extractor looks like this, basket extractor looks like this, and rotocell extractor looks like this. So only Hilsbrand extractor looks like this. So option A is correct. So it is clear to everyone.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
So let's solve one more question. A modern rice mill of 4 ton per day capacity is milling parboiled paddy under optimum operating conditions. The paddy has 20% rice husk and 4% bran without fine brokens and germs. The bran has 20% oil if 98% of oil is extracted by the solvent extraction method. So, how much bran in kg will be available during a month, which is 30 days, and how much of the bran oil in kg available during 30 days in time in period. So we need to calculate bran and bran oil amount. So let's solve this question. We have given capacity of rice mill as 4 tons per day. So it is in per day. So we can understand that in 1 month it will be 4 into 30. So 120 tons per month is the capacity of the rice mill to process the paddy. Then paddy has 20% rice husk. It is given that 20% rice husk and 4% bran. So paddy has 20% rice husk. So when we mill, this husk will going to remove, and if the husk will remove, what we will get? We will get a brown rice. So like this, if rice is there, so this is the internal part. This is the husk part. So this husk will, first is husk layer, then second layer is the bran layer, and then is the white rice. So if we remove this outer layer husk, then bran will be there on white rice, so which is known as brown rice. This brown rice. So brown rice, we obtain a product which is brown rice and it has the bran but not the husk. So total amount of the brown rice means we are removing the 20% rice husk and we are considering 4% of the bran. So total amount is total amount of the paddy into rice with bran. So this 20% if we remove from 100%, so 100 minus 20, so 80%. 80% is the rice which is without husk. Like then if we talk about with one where we have rice about 120 tons, and into 80% is the rice with bran. If we remove the husk part, so 80 divided by 100, which is 0.8. So total amount of the rice, which is 120 tons, which we are processing, sorry, total amount of paddy, which is 120 tons, which we processing in 1 month, into zero point 0.8, which is 96 tons. So 96 tons we get the brown rice when we process 120 tons of the paddy. Then 4% is the bran. So it is when we remove 4% of the bran also, then we are going to get the white rice. So when we polish the rice, so amount of the, we need to calculate amount of the rice bran. So rice bran amount is 4%, which is 4 by 100, which is 0.04 into the brown rice amount, which is 96 tons. So 96 into 0.04 is 3.84 tons, which is 3,840 kgs. So this much amount of the rice bran per month is producing. So calculate how much rice, how much bran in 30 days is 3840, option D. Then we need to calculate amount of the oil extracted. So amount of the oil extracted equals to oil content in the bran into amount of the bran into efficiency of the extractor. So the oil content in the bran is, as given in the question, 20% oil. So 20% means 20 divided by 100 into 0.98 is the F is the, if 98% of the oil can be extracted, so extractors cannot have 100% efficiency. So this extractor is having 98% accuracy or efficiency. So into 98 divided by 100 into 3840, which is amount of the rice bran we just calculated. So when we multiply all three, we will going to get 752.64 kg of the bran oil in 30 days of time. So option D is correct. Is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. I don't know why this is switching off this camera again. Hmm. Anyway, let's move to the next question. So next is also a numerical problem. So a synergistic oil blend is there which is prepared by mixing soybean oil and sunflower oil. If 600 kg of the soybean slurry, which is having 20% oil and 80% meal, is blended with sunflower slurry, which is having 35% of the oil and 65% of the meal, then what is the total amount of the sunflower oil slurry mixed to get a final slurry mixture with 30% oil? So we are mixing two oils which are soybean slurry and sunflower slurry, and we are getting the blend of the oil. Please, anyone will try to tell which approach we should take here, how to solve. So what we are doing here, it is given that weight of the soybean slurry is equals to 600 kg. So we know that 600 kg we are feeding soybean slurry which is having 20% of the oil, and we are blending with sunflower slurry, which is, we don't know the amount, but we know that 35% of it is oil, and we are getting a final slurry mixture which is, the amount is unknown, and we need to calculate this y amount, and we know that it has 30% of oil in the final mixed slurry. So weight of the soybean slurry is given as 600 kg. Oil content is given 20%. Then we are assuming that sunflower slurry weight is X amount, and the slurry mixture weight is around Y. So if we do the total mass balance, because we know that from this figure we know that total input, we can, whatever is coming as the input is equals to the total mass of the output. So total mass, as per the total mass balance, weight of the soybean slurry plus weight of the sunflower slurry equals to weight of the final mixture. So weight of the soybean slurry is equals to 600 kg, which is given as in the question, plus we assumed sunflower slurry weight as X and final mixture weight as Y. So 600 plus X equals to Y, which is our equation 1. Then, as per the total material balance, the component F, which is 600 weight, into its oil content. So oil content is in the soybean slurry is 20%. So 20 by 100 is 0.2, plus in X, what is the oil content? 35%. So 35 divided by 100 is 0.35 into X equals to Y, which is, Y is having 30% of the oil. So 30 divided by 100 is 0.3. So 600 into 0.2 is 120, plus 0.35x equals to 0.3y is our second equation. Now we have equation 1 and we have equation 2. So we can solve 600 plus x equals to y, equation 1, if we multiply by 0.35, and then if we subtract from equation 2, which is this equation, then this x component will go off, right? So it will be like 600 into 0.35. This equation 1 will look like this, plus 0.35 x equals to 0.35 y. Right? So this is equation 1 now, and we will going to subtract this and this equation. So 600 into 0.35 is, multiply and tell me. Anyone? 600 into 0.35 is
210.
210.
Yes, ma'am.
Yes,
210.
210, right?
Yes, ma'am.
So 210 this side, right? This
Yes, ma'am.
0.35x will going to cancel with this 0.35x and equals to 0.35y minus 0.3 is 0.05y, and in left hand side this is 200, but minus, we need to minus from 120, right? Because equation 2 is having this 120. So what will be the solution? 210 minus 120 is equals to 90, equals to 0.05 y. So y is equals to 90 by 0.05. So which is 1800 kg. So this is the weight of the final slurry. And if we calculate the weight of the sunflower slurry, which is x equals to, so put y value in this equation. So x is equals to y minus 600. So y is 1800 minus 600, which is 1200 kg. So are we getting this answer? Option C.
Okay, ma'am.
Yes, ma'am.
Everyone is getting
Yes,
this
ma'am.
answer.
Yes, ma'am. Yes, ma'am.
Okay, ma'am.
So let's move to the next question. Numerical problem. This one is also we need to solve. So in a single stage batch extractor, 1000 kg of the crushed oil seeds, which is having 19.5% oil and 80.5% of meal, is extracted with 1500 kg of pure hexane. The solid feed and the solvent are charged in the extractor and keep in intimate contact. The mixture is then allowed to settle for oil diffusion. After a certain time, the solute concentration in the underflow and the overflow streams were found to be 0.04 and 0.114 respectively. Calculate the total percentage of oil extracted in the overflow stream. So this is also a kind of mass material balance question. So the underflow and overflow is basically what happens when we are extracting oil, after the extraction, there is this mixture of uh, oil and solvent. So we have this mix, all is mixed, right? But if we keep oil and solvent mixture for some time, then because of the gravitational force, there are two layers formed. Why? Because there is the difference in the density of the oil and the solvent. So we can get two different layers, right? So we can call one layer, the below layer, as underflow layer. So underflow stream, this is underflow, and this is overflow stream, right? So it is asking, the question is asking the oil extracted in the overflow stream. Oil density is less, so it will always be at the top. So oil will be extracted out from the overflow stream, right? From overflow stream. So we need to calculate oil percentage in this overflow stream. So let's see the solution part. We are giving some feed, right? The crushed oil seed feed as 1000 kg. So we are giving it to the extractor, single stage batch extractor. And then we have the pure hexane as the solvent S, which is 1500 kg pure hexane, right? And here in the extractor, it is going, and one we are getting overflow stream, which is having low density. We are taking its amount as V, and the underflow stream amount L, we are supposing, which is of the high density. So, so in the feed, which is this oil oil seeds, which crushed oil seeds, in this the oil concentration in the feed is equals to 19.5%, which is 19.5 divided by 100 is equals to, its amount is 0.195, right? Then the concentration in the solvent, the oil concentration in the solvent will be 0 initially. Here it's 19.5 because the crushed seeds will going to have some amount of the oil, which is 19.5% as per question. But in the solvent, there will initially be no oil because it is going to be extract, right? So initial value of the oil in the solvent is equals to 0. Then the solute concentration, which is a concentration in the overflow stream, is given as 0.114 in the question, that this 0.114 in the overflow, and in underflow it's 0.04, and its amount we supposed as L, and for overflow it's V. So now if we apply total material balance, it will be total input mass equals to total output mass. So input is feed and solvent. So amount of the feed F is plus amount of the solvent S is equals to amount of underflow plus amount of the overflow equals to total mass of input or output. So it is a equals to whatever total amount we are putting, which is we are considering as M. So M is equals to feed plus solvent. Feed amount is 1000 kg and solvent amount is 1500 kg. So 1000 plus 1500 is 2500 kg. Now solute balance we will apply, which is feed and the amount of the oil in the feed plus solvent amount into amount of the oil in the solvent is equals to total amount into the amount of the oil. So feed amount is given as 1000 kg into the oil percentage is 19.5% or 0.195 plus the solvent is 1500 kg into amount of oil in this is 0. So multiply by 0 equals to m. We just calculated the total mass is 100,000 plus 1500 is 2500. So 2500 into the oil or the solute concentration, which is we are considering it as xcm. So the solute concentration, which is the oil concentration in the total material, is equals to this. How we are getting? Because 1500 into 0 is 0 and 1000 into 0.195 is 195, and on the right hand side we have 2500 into the solute concentration of the total material. So solute concentration in the total material is equals to 195 divided by 2500. So we will get 0.078. This is the amount we get in the for the oil, the oil concentration in the total material. So after some time, when we are extracting the overflow and the underflow these streams, so we will apply material balance. So material balance, as per the material balance, the output, which is L plus V, which is the overflow and the underflow amount, equals to M. So M is 2500 kg, right? So we calculated here M value already. So 2500 kg is the M value. So L plus V equals to 2500 kg. L and V values are not known to us. So total solute, as per the total solute balance, L, which is the amount in the underflow, into its oil concentration, which is given as in the question 0.04. So 0.04 into L plus V into, which is in the overflow. So V amount and its solute concentration, which is 0.114. So 0.114 into V equals to, in the total mass, which is M. M is we calculated as 2500 into, we calculated in this here that there is the solute concentration in the total material as 0.078. So into 0.078. So we can simplify it. 0.04 into L plus 0.114 into V equals to 2500 into 0.078, which is 195. So this is our equation 2. Now this is equation 2, and equation 1 is this: L plus V equals to 2500 kg. Now what we can do is we can multiply this equation 1 with 0.114 and then we subtract from equation second. So this will be 0.114 L plus 0.114 V into 0.114 into 2500, right? So if we this equation will be something like 0.114 L plus 1114 V equals to 2500 into 0.114. So what is the value of multiply this and tell me 0.114 into 2500 value? What is this value? Please, anyone?
285.
25.
285, ma'am. 285.
285. Okay. Thank you. So this is 285 and 0.114 this will cancel out with this, right? So it will be 0.114L minus 0.04L, which is 0.074L equals to, this is 195 and it is minus with 285, which is 90. So 0.074L equals to 90. This is the simplified form. So L will be 90 divided by 0.74, which is 1216.22 kg. Now value of L we can put in equation 2 and we can solve for V, which is V equals to 1283.78 kg. Now amount of oil extracted in the overflow will be V into the amount of the overflow into the amount of the solute part. So which is V into YCV, which is 0.114 into weak value we just calculated as 1283.78. So it will be 146.35 kg. And we know that the initial amount of the oil in the feed is 1000 is the amount of the feed into this is the amount of the oil, which is 0.195, which is equals to, after multiplication we will going to get 195 kg. So the percentage of the oil extracted is equals to the amount of the oil extracted in the overflow divided by the initial amount of the oil in feed into 100. So amount of the oil which is extracted in the overflow is 146.35 divided by initial amount of the oil in the feed, which is 195 into 100. So the value is, for the percentage of the oil we extracted, is 75.05%, which is near to option A. Is this question clear to everyone?
Yes, ma'am. Okay, ma'am.
Okay, so we are moving to next question. Everyone is fine?
Yes, ma'am.
So let's solve another numerical. So 1000 kg of the soya bean we have, which has 20% oil, 35% protein, 27.1% of the carbohydrates, 9.4% of the fibers and the ash, 10.5% of the moisture. And we have the crushed and pressed, uh, by crushing and the pressing, the oil content is reducing to 6%. And in B, it is saying the extracted with the hex, when we are extracting the meal with the hexane, then it will have further, like first we know that we first do the mechanical pressing. So by mechanical pressing we get 6% of the oil, and then with the solvent extraction by hexane we get final oil content in the meal is 0.5%. So we need to set up the material balance, and we need to calculate the amount of the oil which is obtained through the pressing and amount of the oil which is we are getting through the solvent extraction process. This is very good question. Please try to solve this. It is more like it is similarly to the previous questions which we discussed. So let's discuss. So the first part, we will start with the first part. First answer is B. So let's see how. So it is given that the weight of the soybean is 1000 kg and the amount of oil is 20% and amount of the non-oil constituents remaining constitutes 80%. So as per the mass in the oil percent, which is 20 by 100 into 1000 kg. In 1000 kg, we have 20% of the oil. So 20% of 1000 kg is 20 divided by 100 into 1000 is equals to 200 kg of the oil, which is ingoing. The 200 kg of the oil is there in the when we are feeding. So, and rest is the non-oil constituents, which is 80% of the 1000 kg. So, 80 divided by 100 into 1000 is equals to 800 kg. So, 800 kg is the non-oil part and 200 kg is the oil part. Now, let's see the what we are getting in the output side. So in the output side, when we are doing the crushing and the pressing, which is the mechanical pressing operation, then we have in the original beans around 800 kg non-oil constituents. So that are the and we have 200 kg of the oil constituents. And it is given in the question that percentage composition of oil constituents in the crushed and pressed soybean is 6%. So, in the pressed material, around 94% is the non-oil part and 6% is the 6 parts is the oil part. So, total oil which is expressed or which we get in the output is equals to 6% oil divided by 94 is the non-oil part into 800, because 800 is the meal part or the meal or the what we say non-solid non-oil part. So 800 is equals to 51.06 kg is the total oil expressed in the material. So quantity of oil obtained through pressing is this 6% oil is there in the, like, what is happening, we have around 200 kg of the oil and we have 800 non-oil, right? After the mechanical pressing, we get around the meal which is having 6% of the oil. So we calculated this amount, that what is its amount first. So its amount is 6 in 94, which 94 is non-oil part into 800, because 800 is a part which is the non-oil part. So equals to 51.06 kg is the total oil which we get, the amount which we get here. So in this process, mechanical pressing process, we will going to get 200, which is the initial amount, minus the 6% value, which is 51.06 kg, equals to 148.94 kg of the oil we will going to obtain from the pressing. So option B is correct. Is this question, this part is clear?
Ma'am,
No,
can
ma'am.
you tell
This
me
is not.
four parts
This is
and
not
six
clear,
parts
madam.
in oil?
Please, one by one. Please, one by one.
Ma'am, actually, the here is written that reducing the oil content to 6%, then it should be reduced from the 200 kg, na?
So what is happening? We are reducing from 200 kg, right? Like from 200 kg, we are minus, we are doing minus this value, right? Because when we are feeding the oil, right? So once we are feeding the oil, then we will not going to get the 100% extraction. We are getting some extraction, and like 6% is not extracted. So we are doing minus here. Why we are multiplying with 800? Because see, 94 part is the oil, is the non-oil, right? Which is 800.
Ma'am, I have a request. Can you please explain from the beginning?
Yeah, yeah.
Actually, I'm not understanding any of the things about this question.
Okay, okay. So let's start from mass in. So we have this, see what is happening in this question. First, we are putting soybean, which is 1000 kg. Okay. And in this, first we are using mechanical pressing, and then this meal will further going to feed into solvent extractor, and then finally we will get these two process we will apply here. So this, from this, 6% oil is not extracted. Here, after applying this solvent extraction process, in the meal we have 0.5% of the oil. That means 0.5% of the oil is not extracted, right? So this, first we are seeing that 1000 kg of the input of the soybean we are putting, in which 20% is the oil and 80% is the non-oil part. So if we calculate in kg, so oil part is 20% of 1000 kg, which is 20 divided by 100 into 1000, which is 200 kg. And in the non-oil constituents, it is 80%, which is 80 divided by 100 into 1000. So it is 800 kg. So 200 kg is the oil, 800 kg is the non-oil part, which we are feeding. Now it is going in the mechanical pressing, right? Where we will get output, in the output meal, it is 6% oil. So we know that in the, from the question, that a part is this: crushed and pressed, reducing the oil content to 6%. That means in 100 we have 6% of the oil. 100 we have 6% of the oil. That means 100 minus 6, which is 94. So 94 is non-oil part. So 94 is non-oil part, which is having 800 kg of the weight, right? Because this 6% oil is there in this part, 800, right? When we, it is mixed with this part, right? So when we do unitary method, it will be 800 divide by 94 in, right? When we take one part of the non-oil part, it is having 800 by 94. So we are having 6% of oil. So multiply by 6. So 6 we have 6 we are having oil part, divide by total kg we are having 94. Sorry, total percentage or total portions we are having 94 into total kg we are having 800. So the meal is which is equals to 51.06 kg. So 51.06 kg is remained in the meal part of oil. This much of the oil is left in the meal part. So now what, from the total we are feeding 200 oil, out of which 51.06 oil is left, is in the, is here, it is not extracted out. So total will be 200 minus 51.06, so 148.94 kg of the oil we obtained through pressing. Now is it clear?
Yes,
So
ma'am.
okay, so the person which was having doubts, is it clear? The
Yes,
student
ma'am.
which, now you
Yes,
have,
ma'am. Yes,
you
ma'am.
are clear. Okay,
Yes, ma'am.
so next we are moving to the second part, which is about from the oil, which is from the extraction process we are getting, right? Solvent extraction process. So from in this question, it is given that final meal is having 0.5% of the oil, right? So in extracted meal, 99.5% is the non-oil part and 0.5 is the oil part, right? So total oil which is extracted in the meal is 0.5 divided by 99.5 into the amount 800, which is 4.02 kg is the oil in the meal. So oil which is extracted solely in the solvent extraction is, because in the solvent extraction we get 51.06 oil. Now in solvent extraction we are getting 4.02 as oil. So 51.06 minus 4.02 is equals to 47.04 kg of the oil is extracted using the solvent extraction, and we are losing around from the input is 200, right? So from 200 kg of the oil we are losing around 4.02 kg of the oil is lost, and rest is recovered from the extractor, out of which around 148.94, which is this, around option B, it is extracted from the mechanical pressing, and 40 around 46 to 48 kg is extracted using the solvent extraction process. So is it clear, this whole question?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Clear to all, right?
Yes.
Yes,
Yes.
ma'am.
So let's move to the next question. So in the column A, we are having some statements, and in column B, we are having some processes. So in A statement is saying that the separation of compounds based on the differences in melting and precipitation point. B is saying that treatment of oil with caustic soda, and C is saying precipitation based on the solubility in the water. And we have three terms: degumming, winterization, and neutralization. So which is connected to which? which is degumming, which is what is known as
Option A, ma'am.
neutralization and winterization.
Option A.
So we
Option
got
A, ma'am.
A.
option A, which is correct. So when we have oil, we go for its water or acid degumming. Then the degummed oil can be for in which the phospholipids will going to remove, and there can be two type of refining can be done, like physical and chemical refining. In the physical refining, we go for bleaching, where pigments, metals, and soaps will be removed. Then winterization, where the waxes will going to remove. Then deacidification or deodorization, where the volatiles, fatty acids, sterols, acids, they are removed, and we get the final refined oil. Whereas in the chemical refining process, the degummed oil, it is going to be neutralized and then bleached, where again the pigments, metals, and the soaps will going to remove. Then winterization, where the waxes will remove, and finally deodorization, where the volatiles or the fatty acids or the sterols acids, they will going to remove. So in the winterization process is the process of dissolving the extract in the ethanol, then placing the mixture in the freezer to cool down or to chill. The cool allows for the separation of the compounds based on the differences in the melting and precipitation points. In the cooling process, the fats and the waxes with higher melting point will precipitate out and can be removed by filtration, centrifugation, decantation, or other separation process. In the degumming, we pass hot water through the oil to precipitate out the gums and the proteins that are soluble in water but not in the oil. Then discarding the water along with the impurities. And in neutralization or the deacidification process, the oil is treated with NaOH or sodium carbonate Na2CO3 to pull out free fatty acids, phospholipids, pigments, and the waxes. So we have option C as our correct answer. So everyone was correct. So we are moving to the next question, which is about blanching. So in a wet blanching system, feed oil should have dash percentage of the oil and should be at blank torque operating pressure in bleacher reactor. So this kind of system is we can see in the diagram. It is a wet bleaching process. So in this diagram, we can see also what is the pressure we are applying.
Option A, ma'am.
Option A,
Option A.
option A, okay. Yes, you are correct. Option A is correct. So bleaching is a basically physical process where the impurities in the oil, they will be removed out, particularly the pigments, and other related compounds, which are removed with the help of a adsorbent. So the impurities and the active sites on the adsorbents, they are attract to each other using the van der Waals attraction, and in on the adsorbent the impurities will attract, they'll deposit, and then it will be removed. So there are two bleaching process, one is dry bleaching and another is wet bleaching. So bleaching in the dry bleaching, water washed and vacuum dried oil which is having less than 1.1% of the oil is feed in the vacuum bleacher where only bleaching clay is added. So here it is less than 0.1% oil, so it is known as dry bleaching. Whereas in the wet bleaching process, moisture content in the feed oil, it is 0.2 to 0.4%. Because of the low moisture, benefits of the wet bleaching is not accomplished. So when we are decreasing the moisture very low, like less than 0.2%, we cannot get better, good wet bleached product. So we should keep in this limit 0.2% to 0.4%. But at the higher moisture content, which is 0.4%, premature blinding can happen, which means that adsorbent materials, it can become clogged or blocked in too early in the process. So mature blinding of the filter screens or the blocking of the filter screens can occur if moisture content is very high. So moisture should be in this range. Next, we should talk about the pressure. So the absolute pressure in the bleacher reactor should have an operating pressure of 500 torr. We can see in the figure also. We take here as 500 torr. So 500 torr, because due to the high pressure of the oil would have higher moisture content. If we apply more pressure than this, then moisture content will be higher, and if we apply low pressure, then oil may get too dry. So we cannot do wet bleaching process. After 20 to 30 minutes of the contact time between the oil and the clay, the oil leaves the vacuum reactor and enters into the vacuum dryer, where before final release, the moisture content will be reduced down to 0.1%, less than 0.1%. So option A is correct in this case. So far, is it clear to everyone?
Yes, ma'am.
Yes.
Yes, ma'am.
So let's move to this question where we have some type of deodorizers. So which type of deodorizer is suitable for emulsifiers and interesterified products? Semi-continuous, continuous, batch, horizontal, continuous. So batch is the correct answer. So there are the deodorizers. So in deodorization step, which is the last step in the refining process, the odors and the flavors of the fats and the oil, they are going to be removed. Like oil will going to be in the bland finished product, and this in this deodorizer vacuum is maintained. Usually there are different steps in this, like first de-aeration of the oil is done, then heating of the oil is done, after that the steam distillation, where actually the volatile compounds or the odorized compounds they will remove, and then citric acid treatment, and then further the cooling. There are different types of the deodorizers like batch, semi-continuous and continuous. Batch deodorizers which look like this. So in the batch type deodorizer, there is a vessel in the form of a vertical cylinder with dished or cone heads, this head. The stripping steam is injected into the bottom of the vessel through a distributor, and then the steam is passed through the bleached oil to heat the incoming oil. And the main advantage of this type of deodorization system is they have the flexibility of the incoming oil, so the process parameters can easily be adjusted according to the incoming oil quality. So it favors emulsified and inter-emulsified products. So emulsified and inter-emulsified means emulsification. In the emulsified product, emulsification happen, which is the process of breakdown of the fat into smaller pieces, whereas in the inter-esterified product, it is the process of rearranging of the fatty acids within the fats. So this type of the batch uh, deodorizer is there, which is suitable for emulsifier and inter-esterified products of oil or the oils, since it is flexible in terms of incoming oil. Okay, is this question clear to everyone?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
So let's move to the next question, which is about the deodorization system only, that what is the function of scrubber in the deodorization system. First is of the volatile components, second is the crystallization of the triglycerides, third is prevention of vortex formation, or fourth is movement of oil downwards. So we just saw this is a kind of a deodorization system. So what is the function of scrubber here? Anyone, please?
Options, ma'am.
C.
Prevention of vortex formation.
Ma'am, D.
Ma'am, the movement of oil downwards.
Anyone else? A. Condensation of the volatile components. So condensation of the volatile components scrubbers do. So this is a kind, like it basically, this diagram is taking from the double scrubber section within a continuous deodorizer. So this is a cold scrubber here. Two scrubbers are here in this system, cold scrubber and hot scrubber. This is just an example to show where scrubber actually locates in a deodorization system, and what is its function is it the the vapors leaving the deodorizer consist of the steam, volatile compounds, fatty acids, sterols, tocopherols, contaminants, etc. So, or minor amount of mechanically entrained neutral oil like mono, di, triglycerols, and some non-condensables like airs. So, it what it do is condensation of these volatile compounds is achieved by the scrubber and result in the byproduct called the deodorizer distillate is the its byproduct. So usually what is happening, these volatiles which are removed using the deodorizer system, So all this scrubber, it is going to condensate the volatile compounds, and the final resultant we get as a deodorizer distillate. In physical refining, a deodorizer distillate fraction, it is having such, like this is an example where the deodorizer is producing some deodorizer distillate, and it has, like when we are doing the physical refining and when we are doing the chemical refining, so it has these kind of compounds present. So in physical refining, a deodorizer distillate fraction is rich in tocopherols, sterols, and can only be obtained through the double scrubbers. So the vapor phase is first going to condensate at the higher temperature, which is the hot, which is going to give the hot distillate in which the least volatile compounds like the tocopherols or the sterols are concentrated. Then the complete condensation will going to happen of the volatile compounds, which includes mainly the free fatty acids, in the cold scrubber. So first we will going to apply the hot scrubber and then the cold scrubber to get the final distillate, uh, like the final distillate. Like this is the, it is telling this is the after the physical refining of the palm oil, we are getting such kind of, like such kind of the distillate, and this is from the chemical refining. So we have option A as correct, condensation of the volatile components. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, yes.
Yes.
Okay, thank you. Thank you, students. Let's move to next question, which is about hydrogenation. So which of the following is required condition for the hydrogenation process? Temperature from 121 to 232, or 80 to 100, or the pressure from 100 to 60 pounds per square inch cage, or from 80 to 120. Which option is correct about hydrogenation process? What is hydrogenation process? Please, can anyone help? What is hydrogenation of oil?
In
Ma'am,
hydrogenation,
hydrogenation is a heterogeneous reaction process which is complex in nature, where the reaction occurs between hydrogen and liquid phase, converting or all of the
unsaturated
unsaturated
fatty
to
acids
saturated.
to saturated fatty acids.
Hmm. Both of you are correct. So option A is correct here. First, let's discuss about hydrogenation. So a heterogeneous reaction. This is a heterogeneous reaction where what is happening? Hydrogen, which is in the gaseous state, and unsaturated fatty acid, which is in the liquid phase, they are converting to the, like in the saturated one. So converting unsaturated fatty acid into the saturated one. So in the hydrogenation of the vegetable oil, we can see in the reaction that this is the unsaturated vegetable unsaturated fatty acids, and hydrogen we are using, and we can use any catalyst, like usually the metals like nickel. So it will going to break this bond, and we get the saturated fatty acid, which is this. So hydrogenation is accomplished in a reactor where hydrogen gas is bubbled through the oil at a suitable temperature and pressure in the presence of the catalyst. So catalyst, basically what it do is, it increases or accelerate the reaction but doesn't consume in the reaction. So oil may be selectively hydrogenated with the temperature and the pressure ranging from 121 to 232 degrees Celsius at 10 to 60 pounds square inch gauge. This temperature and this pressure range, and mostly we use as a catalyst as a nickel. So option A is correct. Is it clear, this question, to all of you?
Ma'am.
Yes, ma'am.
Yes, ma'am.
Next question is, thank you. Next question is about, in the hydrogenation only, there is a simplified reaction model like this, where linolenic acid is, and then linoleic acid, oleic acid, linoleic acid, oleic acid, and stearic acid, they are there. And this is SL, which is selectivity. So SL1 equals to K1 by K2 is given. So it is telling which acid selectivity.
Option A.
Option A, ma'am.
A.
Linolene.
Linolenic.
Linolenic, right?
Yes, ma'am.
Everyone is everyone is on the same page, right?
Yes,
So
ma'am.
in triglycerides, there are linolenic acid, linoleic acid, oleic acid, and all of they are going to hydrogenate at different rates. So there is the different simplified reaction model, which is this. It makes, it is defining the selectivity of these. So linolenic selectivity is SL1 equals to K1 this by K2. And if we talk about linoleic, then SL2 is equals to K2 this one divided by K3. So in this model, the concentration of hydrogen at the surface of the catalyst is not considered, and the rate constant it will influence by temperature, catalyst, and the process parameters, which impacts the concentration of hydrogen at the catalyst surface. So we have option A, linolenic acid selectivity, as correct answer. So now we are discussing next question, which is about the chemical interesterification. So zinc acetate, sodium ethylate, tin acetate, and aluminum acetate, we have these as catalyst, which, so we need to tell which is not utilized catalyst in this particular process, chemical interesterification process.
I think aluminum acetate, ma'am. Option D, ma'am.
Aluminum acetate, one we get as aluminum acetate.
Ma'am, option C.
Tin acetate as second option
Ma'am,
we get.
option C.
Tin
Ma'am, option
acetate.
C.
Tin acetate low. This is than aluminum acetate. So, anyone else? Anyone is having any other option than C and D? So first discuss about interesterification, what it is. So interesterification, it is the redistribution of fatty acid moieties present in a triglyceride oil over its glycerol moieties. it implies that there is a breaking and reforming of the ester bonds like this that connect the fatty acid chains to the glycerol hubs of the fat molecules. So there are two kind of reactions where catalyst is inorganic chemicals, so chemical esterification, where the catalyst is like, or the rate of the reaction enhancer is enzyme, so it is known as enzymatic interesterification. This process is typically used to adjust the physical characteristics of the oil or the fat, like by the, like we modify the fat using interesterification process to convert, to change its melting point or its plasticity or any other physical characteristic we change of the oil as per our desired requirement or desired need. So there is this example where this one is the triglycerides, where there is these two as these two chain as linolenic acid residues and one is stearic acid residue. And in this triglyceride, the bottom one, this one, we are having three stearic acid residues. And when it is going in the interesterification reaction, there's the modification reaction, then we are going to get two molecules of the triglyceride which is having two this chain and this chain, two as stearic acid residue and one chain as linoleic acid residue. So there is the modification. Linoleic, one is linoleic and one is steric, right? So there is this modification happening. So interesterification like this is happening. So as we know, there are two methods, which is chemical interesterification and enzyme interesterification process. So in the chemical, what is happening? Chemical, the catalyst is inorganic compounds such as the sodium methoxide, and the reaction is carried out at very high temperature and creates three byproducts like sodium, soaps, fatty methyl esters and monoglycerides in addition to the interesterified fats. And in the enzyme interesterification process, it is the enzyme which is breaking and reforming the ester bonds. So can you please mute? There is some noise. Thank you so much. So the enzymes most suitable for this process is esterase, lipase, silase, and those enzymes which facilitates the acidolysis reaction, transesterification reaction, ester synthesis, ester interchange reactions, enzymes having the phospholipase, protease activity or the protease activity, which includes the thermostable or the thermotolerant hydrolase activity and polynucleotides. So these kind of the enzymes, they participate in the interesterification process. So coming to our question, option D is not utilized catalyst in the chemical interesterification. So the acid bases and their corresponding salts and the metals, they are basically used in the interesterification process, which can be subdivided into the high or the low temperature groups. So in the high temperature catalysts, they include mostly the metal salts such as the chlorides, carbonates, oxides, nitrates, acetates of zinc, lead, iron, tin, and cobalt. So this is tin acetate, and we have zinc acetate. So they are usually used in the high temperature catalyst, and low temperature catalysts they include alkylates like methylate and ethylate of sodium and sodium or potassium alloy. So this is sodium ethylate. So this is a low temperature catalyst. So only the aluminum acetate, it cannot be used or utilized as a catalyst in the chemical interesterification process. Is it clear this question to all of you?
Yes, ma'am.
Yes.
So let's move to the next question. So this is a question numerical. Let's solve this question. For enzymatic interesterification, a spherical reactor of 2-meter height is filled with with peanut oil of specific gravity 0.92. If the pressure measured at the highest point in the reactor is 70 kilopascals, then the total pressure in the reactor is. So there is a spherical reactor which is having height as 2 meter, and it is having peanut oil in this, which is having specific gravity as 0.92, and the pressure which is at the highest point means surface, right? So pressure at the surface is 70 kilopascal. So we need to tell the total pressure. So how we can convert this specific gravity into density? How this specific gravity and density is correlated? How we can convert? Anyone? Please, anyone can share his or her opinion. Conversion of specific gravity into density. Okay, let's solve this question. So the specific gravity of peanut oil is given in the question as 0.92. Height of the reactor is given as 2 meter, and the pressure at the surface, which is the highest point, is 70 kilopascal. We need to calculate the total pressure in the reactor. So the density of the oil, we can calculate the specific gravity of the oil into the density of water. So density of water is 1000 kg per meter cube. So the density of oil is 0.92, which is its specific gravity, into 1000 kg per meter cube. So it is equals to 920 kg per meter cube. Then H is given as 2 meters, and gravitation acceleration is 9.81 meter per second square, which we know already. So pressure at the bottom is equals to rho gh, like pressure due to the gravitational pull is rho g, sorry, rho gh, right? So rho is the density. So we know density we calculated as 920 kg per meter cube. So this is rho. Then height is h is 2 meter into g, which is acceleration due to gravity is 9.81 So when we multiply 2 into 920 into 9.81, it is 18,050 Pascal, which is 18.05 kilopascal or 18.1 kilopascal. And the total pressure in the reactor is pressure at the surface of the reactor plus pressure at the bottom. So which is equals to pressure at the surface is 70 kilopascal given in the question, plus the bottom pressure is 18.1 kilopascal, which we just now calculated. 70 plus 18.1 is 88.1 kilopascal. So option B is correct. Is it clear to everyone?
Okay, ma'am. Yes,
Okay,
ma'am.
Yes, ma'am.
thank
Yes, ma'am.
you. Okay, so can we move to next question now?
Yes.
Okay, so this is a matching question, match the following. So in the column A, we have methods for measuring lipid oxidations. So we have different values like iodine value, peroxide value, tensimate value, and anisidine value. And in column B, we have their respective measuring units like induction time, iodine absorbed by 100 grams sample, C Totox or oxidation value, and D is milliequivalents of oxygen per kilogram of fat. We need to match these, which method is like how to we calculate it.
Option A, ma'am.
So option A.
Option
Option
A, ma'am.
C.
Option C.
Option A.
Option A.
So we are getting more or more as option A.
Option A, ma'am.
So many of us are saying option A. So please, can anyone uh, share how you are solving this?
Ma'am, iodine value, it is iodine absorbed by a 100-gram sample.
Okay.
Pero and the peroxide value, which is milliequivalent equivalent of oxygen per kilogram of fat.
Hmm.
And the other two, I don't know, ma'am.
Okay. Can anyone help her to tell another two?
Madam,
Please.
aniside is aldehyde level of oil.
Okay. And rancimate. So they two are correct. Both of them are correct. Now we know the rancimate method for induction time. Let's see. So A is correct. So the peroxide value, basically peroxides are measured by the techniques based on their ability to liberate iodine from potassium iodide using the iodometry, which is a chemical analysis techniques that uses iodine to determine its concentration of the oxidizing or reducing agents. So the peroxide value is usually expressed as milliequivalents of oxygen per kg of the fat, as she rightly mentioned. So this is the reaction. What happens is, like, yes. So what is happening? First we have this our fat. So this potassium iodide, it will bind and replace this H and form with, this is K, it will form, right? And Hi will be separated out. This Hi, it will going to react with peroxide, which is ROOH, and it will going to form, this water will go out, and H iodine will go out, and this RO plus H will alcohol, this alcohol will going to form. When we do the titration, then this iodine, it will convert from purple to no color. So we can understand that this much of the value at this much of the volume of the iodine, this much of the volume of the Na2S2O3, that iodine is disappearing. So we can, the color, purple color is disappearing. So we can understand the how much amount of the iodine will be there. So from amount of the iodine, we can understand how much amount of the Hi will form in this particular product, and from the Hi amount we can understand this value of the like the amount, how much is the uh, fat is there. So we can understand how much of the from the peroxide we can understand that how much of the oil is there, or sorry, how much of the oxygen is there in the per kg of the fat. Next is the anisidine value, which is in the presence of the acetic acid. What happens? This para anisidine, it will going to be react with aldehyde and producing a a yellow color chromophore or yellow color forming compound will form, and uh, it is usually expressed in the totox or oxidation value, which is equals to 2 into peroxide value plus anisidine value, and it is used for the assessment of oxidation in the oil. Then iodine value is determined by reacting the fats with a solution of the iodine monochloride, or reacting of the, basically it tells amount of the unsaturation. So iodine will going to react with the unsaturated fatty acid, which forms the saturated fatty acid, and we will going to know what is the amount of the degree of the unsaturation. So fat, it can react with the iodine monochloride in the mixture of the acetic acid and CCl4 and liberates the excess iodine with Ki, and we can titrate it with Na2S2O3 and can know the amount of the grams of the iodine absorbed by a 100-gram sample. The reaction is same like this in case of iodine value. And last is the Rancimet method, in which air is bubbled through the oil. So in this we have oil and air, we will put air in this sample where oil is there. So bubble will going to form, and based on that there will be some increase in the electrical conductivity of the sample. So from that, like what happens, oil react with the air, so there will be oxidation. So because of the oxidation products, the electrical conductivity of the oil will change, and then we will measure the electrical conductivity and can know the how much oxidation happens. So it usually done at 100°C and is expressed in induction time. So this kind of setup we generally use for calculating the for measuring the Rancimet method. So this is the last discussion we are having today, and topics which we covered today today includes, like we discussed about extraction of the oil extraction techniques like the mechanical and the solvent extraction, We discussed about factors affecting the extraction process, expellers, and we saw the numerical on expeller also. Then and working principle of extractors and the numerical on the mass material balance we solved in the extractor. And then refining of the oil we discussed. In that we discussed about degumming, blanching, neutralization, sorry, bleaching, neutralization, and then we discussed about the deodorization system and the refining, like the physical refining. We discussed about chemical refining also, and then about the modified fats like hydrogenation, interesterification. In the interesterification we discussed about the two interesterification process like chemical and enzymatic, and then we discussed about winterization process. And in the next week we will going to discuss about rancidity, natural antioxidants, microencapsulation, food nanotechnology. And if you have any doubt in today's lecture, please feel free to ask.
Madam, you shared us a link of Google Drive, and
Okay.
that link does not works, madam. Or actually,
Is
ma'am, you are showing the PPT now, so we cannot copy from this. Can you please give the link in the chat box?
uh, first this link you want in the chat box, right? Of the
Yes, ma'am.
of this.
Google
Actually,
Drive.
this, can anyone tell that is this link working? This link is working for all?
No, ma'am.
Not working. You cannot open Google Drive folder.
Yeah, it is
Right
working.
now it's opening, ma'am.
Can you
It's working, ma'am.
It is
This one.
working, ma'am.
It's working, ma'am.
for many of these it is working. So can you please check? And this is the link I have just pasted. Can you please try just now and let me know if you can access?
Okay, ma'am. I'm trying, ma'am. One second, ma'am.
Please try. Please try just now.
Yes, ma'am. Now it is opening.
Okay.
Ma'am,
Thank
what
you
is
very much, madam.
K232 value, ma'am?
Thank you,
Please,
madam.
can you repeat?
What is K232 value, ma'am?
Can you repeat? I'm not able to hear you.
K232 value. It's given something like K232 value increase with increase in
Where it is? Can you please
during
tell the
the
reference?
videos, lecture videos.
Hmm.
One was said like K232 value increases with increase in temperature, like that.
Uh, K232.
Yes, ma'am.
What is K232? Can you tell? Like, I'm not able to understand your question. Today's lecture or previous lecture?
No, no, it is this weekend lecture from 30th to 34.
Okay.
Within that only, I got some question like K232 value, which it was a full sentence, but I didn't note it down completely. But it was something like K232 value increase with increase in something. It was written.
Okay, so it will be in there in the lecture slide already
Yes,
shared,
yes,
maybe.
yes, ma'am.
Okay, so you refer from there, or because I need to discuss the last class doubt questions. I want to discuss now.
Okay, okay, ma'am. Just give me a second. Let me.
So in the last class, uh, yes. So we have assignment in the last class. Like this, we in the last class we were discussing about week 5 assignment. Some problems were there. So we discussed about question 3. So
Yes, ma'am.
the
I
question
got
was,
that slide. A significant increase in tocopherol content acid and K232 value with increase in pressing temperature was found. So I was having the doubt ki what's that K232 value
Oh, okay.
during
This
extraction
is
of oil
a,
from groundnut. Yes.
this one.
Yes, ma'am.
So these are the rate constant when
No, no,
there
no,
is.
not this one, ma'am. Sorry. During the lecture videos in the
Can you
class.
share your screen so that I can understand? I can.
Okay, ma'am.
Is
Just
it there in your screen? Can I see?
yes, ma'am. I'm going close to it.
Yeah. So we will discuss till now. Till that time, we will discuss this question. So what is the last class question was? Is in this question there is estimated mass flow rate, and
Yes, ma'am.
they
This
they
this
have
one.
calculated volume flow rate. So as per the this is the volume flow rate formula, and this is volume flow rate only. But if we want to, because there is a slight correction. So for mass flow rate, we need to multiply volume flow rate into density, which is given in the question as this.
Ma'am,
The
it's visible?
density of the wait. Density of we are actually discussing some question. Just wait for a minute. So
Okay.
whenever in the question, if it is given mass flow rate, like here in this question, it is given mass flow rate, but they have in the solution part, they have calculated volume flow rate, right? So uh, for calculating mass flow rate, we need to multiply volume flow rate into density, and density of the extrudate is given as 1250 kg per meter cube. So it should be multiplied with the density. And in the question 19 of assignment 5, this is the question. So there is specific mechanical energy formula. So the question was on, so when we are calculating the mechanical energy, so this they are calculating here 2 pi extruder, uh, 2 pi into extruder screw speed into torque. So this is basically they are multiplying, like the power is calculated. The power formula is P equal power, like power is usually, let me write here. So power P equals to, power P is equals to, usually it is torque into angular speed, which is omega. So this is how power is usually calculated. So first we are calculating in question 19 power P equals to torque into omega. So omega is 2 pi r. 2, this is angular rotation speed, and in the question the revolutions per minute is given. So 2 pi into revolutions per minute. So 2 pi r. So this is given in the question as 25. Please can you mute? It is disturbing. Yeah. So here in the question, for calculating the specific mechanical energy, first this in the numerator it is power P is calculated, and uh, so 2 pi into r, because here 2 pi r is because it's not the angular, because 2 pi r is the angular speed. So angular speed is 2 pi into linear speed, which is 100 rpm given in the question, and then into torque, which is 25 given in the question here as 25. And in the and it is dividing by 60 because it is converting, because in the seconds, because this is given in the rpm is revolutions per minute, not in seconds. So it is by dividing by the 60, it is taking as seconds. But and it is then dividing by mass flow rate. But if you solve this, this is in not correct actually. There is slight changes, like uh, it should not, if mass flow rate is 1 kg per hour, right? Feed flow rate is 1 kg per hour. So you this much is okay, we are converting this in second, and this much is okay, but this 60 we cannot take, because it will be 1 kg per hour, means 1 kg per, if we convert into second, divide by 60. So 1 by 60 is minutes, and 1 by 3600 will be in seconds. So there is also slight changes or slight correction in this question as well. So this was the last class question, and now I am, so isn't it, this was shared with me? Okay. So are you, you are sharing, right? Yeah, sharing the screen.
Yes, ma'am.
Can you please tell your doubt?
Ma'am, in the slide, it's written
Okay.
a
Yes, yes.
significant increase in tocopherol content acid and K232 values with increasing pressing temperature was found.
Actually, I'm not able to see properly. Your screen is
Is that
visible to me. Okay, you tell me the slide number, then I'll clear your doubt either on, because I'm not able to see, or it's very small. I cannot see.
Isn't it? Okay. Third paragraph, a significant
Okay.
increase in
Yes, a significant increase in tocopherol content and K232 value with increasing pressing temperature was found. Can you show your screen? You have changed your screen.
Yeah, yeah, ma'am. Sorry.
Yes. Can you show me the graph in groundnut seed? Okay. So a significant change. Can you slide it towards the point, please? I'm sorry to bother you.
No, really, issue, ma'am. It's okay.
A significant increase in tocopherol content and acid and K232 value. The, okay, so it is basically, it is talking about the reaction constant value. Uh, I will recheck this also, K232 value, but I think this is talking about the rate constant value, that it is increasing with the increase in the temperature. So
Okay.
usually what happens when we are like increasing the temperature in the, then all all different like compounds, like the volatile compounds, everything, they will going to react differently. So I will confirm this your question. Okay.
Okay, ma'am.
Okay. So maybe my screen was not there. Now now is it visible, my screen? I was actually discussing this question, and I think my screen was not visible that time. I'm sorry. Is my screen visible?
Yes, ma'am.
So I was discussing, actually I was discussing this assignment 5 problem, but the screen was not, like, it was not visible that time. So what is happening? There is this week 5 question. In week 5, there is 3 questions. The question number 3 and question number 19, I was discussing. So in question number 3, I'm repeating that mass flow rate is there, and they have calculated volume flow rate.
Understood your point.
Yeah, so
Yeah,
we
for
need to
this I
multiply
understood.
with the density. Okay. And then second,
Yes, ma'am.
question 19 is question 19. Yes. So question 19 is this, where what is happening? Power in this, we are, from this we are calculating the power. Power is P equals to P equals to torque into omega, which is angular angular momentum, angular frequency of the motion, and then angular speed. Actually, exact term is angular speed. So angular speed is given as 2 pi into linear speed, which is revolutions per minute. Here is given 100 revolutions per minute. So we are taking 2 pi into 100 revolutions per minute into 25 is the torque. But it is dividing first by 60, which means here it is 60 because it is converting revolutions per minute into per second. So it is dividing by 60. But there is this like the problem is with the mass flow rate. When we are dividing mass flow rate, which is 1 kg per hour, so they are what here it's slightly correction. It's 1 upon 60 if we take in minute, but we are converting here in because we have taken here as 60, so it will be 1 up in the second. So 1 in divide by 60 into 60, which is 360. So the value will going to be changed, the answer will not going to be the same. So in this question there is also slight correction in the calculation part.
Okay, ma'am.
Okay.
Thank you.
Okay, and the question which we were discussing, K232 value, I will recheck. Please give me some time to recheck. I'm sorry. I don't like. I think that is K232 value is a rate constant, but I'm not sure. So I will recheck and let you know in the next lecture. Is it okay for everyone?
Okay, ma'am.
Yes, ma'am.
Okay. So we are in the end of our today's session. So please join in the on the next week with the same time. Thank you so much for connecting today. Uh, you can leave the meeting now. We have discussed everything.
Thank you so much, ma'am.
Thank you, ma'am.
Thank you
Thank
so
you.
much.